Good morning, my YouTube viewers. It's Crystal here, and I wanted to give you another code review. But before we get into the code review, what I wanted to do is I wanted to talk about a few statistical principles, so you'll have a little bit of understanding of that as we're going into the code review. So the thing that we're going to discuss first is variance. So we look on Google, and it says, in probability theory and statistics, variance is the expectation of the squared deviation of a random variable from its population mean or sample mean. And you get the formula for variance also on Google, so that's good. And here you go. Here's another question. What does the variance mean? The variance of a measure of variability. It is calculated by taking the average of squared deviations from the mean. Variance tells you the degree of spread in your data set. The more spread the data, the larger the variance is in relation to the mean. So that's your variance. And we're also going to check out students' t-test, because that's what we're going to do in the code review. We're going to do a t-test. So a t-test is any statistical hypothesis test in which the test statistics follows a student's t-distribution under the null hypothesis. It is commonly applied when the test statistic would follow a normal distribution at the value of a scaling term and the test statistic were known. Typically, the scaling term is unknown and therefore a nuisance parameter. When the scaling term is estimated on the data, the test statistic, under certain conditions, follows a student's t-distribution. The t-test's most common application is to test whether the means of two populations are different. And so that's what we're going to be doing. We're going to be testing the means of two populations. See if they're different. So what I have done is we're using the Gapminder CSV file to do this. And since I know Python better than I know R, what I did was I wrote the program in Python. And then I translated it into R, because I do not know R as well as I know Python. So that's what I did. So you're going to get the code in Python, and then you're going to get the code in R. Now what I've done previously is I got the code in R and I translated it to Python. But in this instance, we've got the code in Python and we're translating it into R. So the difference between Python and R is Python is a statistics language built for statisticians. And sorry, that's R is a statistics language built for statisticians. But Python is a general purpose language. And so Python has to rely on has to rely on libraries because it doesn't have any inbuilt functions in it, or very few inbuilt functions. So it has to rely on libraries. So for Python, the first thing that we're going to do is we're going to import our libraries. We're going to import pandas as PT, NumPy as NP, matplotlib.plt, .pyplot as PLT, and Seaborn as SNS. And we're going to read this Gapminder CSV file in using pandas. So you can see this is the Gapminder's CSV file, and it has 1,704 rows by 6 columns. Gives you the country, the continent, the year, the life expectancy, the population, and the GDP per capita. So this looks like this is the first time I've ever seen this, but it stops in 2007, so it's actually a little bit outdated because it's about 15 years out of date, but still, nevertheless, it's good goes up to 2007 anyway. And if we had wanted to do more analysis, we could analyze the GDP in the life expectancy, see what the relationship between the GDP and the life expectancy is. So you can see that we've read it in. So what we're going to do is we're going to go to R, and you can see how they do it in R. We read it in DT equals read CSV. So R has that function built into it already. Excuse me, I've had a cold. So you can see we've got the function already. And then we print DDT, and then we do a summary of DDT. So we print it. And then we do a summary. So there's your summary. And then we attach the DT. And when you attach the DT means, it means that it's going to use the data frame in the program. So that's what you're looking at. So we've got a summary. So after we've done that, what we want to do is we want to remove the white space from the column country. So DT country equals DT country dot str dot replace, and then you're just removing the white space from the country. And then what we want to do after we've done that, we want to find out how many unique values we have in the country. And you have 142 unique values. And then what we want to do is we want to print out all of the unique values. And we printed out all of the unique values with the white space removed. So that's what we've done. So we remove the white space in R. DT country equals G sub, and then that removes your white space. And then we want to get our unique value, so we get our DT unique equals unique DT country, print DT unique, and then we're going to print the unique values, and we're going to print the length of unique DT country. So you probably wouldn't even need to do that. You probably would just need to say that, but we're not going to mess around with it, so we'll just keep it as we got it for DT unique equals unique DT country. And then so we print all of the countries. So you can see we've got all the countries with the white space removed, and you can see that there are 142 unique values, same as Python. Then we're going to go to Python, and what we did, I got this little nifty piece of code here that allows you to create a separate data frame by variety for IG and DT dot group country, and then it says globals DT underscore plus string I equals G. And so that was great. That was a great little piece of code. I could have used filtering, but I didn't use filtering. And then so we've got, I decided to do it for the life expectancy in the U.S. So you can see from 1952 to 2007, the life expectancy has increased 10 years, and the GDP per capita has increased as well. And for the UK, the life expectancy again has increased 10 years. And the GDP per capita has increased as well. And it's interesting to note that the life expectancy in the UK is higher than it is in the US. And I think that's probably because in the UK they have the NHS, and people don't have to pay at the point of service for their medical treatment. What they do is it's taxed. So you pay your national insurance contributions and you get free NHS, but it's not free. Your taxes pay for it. Whereas it's different in the US. In the US, you have to pay for your medical care at the point of service. And so if you haven't got any money, you don't get any treatment. But they do have like Good Samaritan laws to where if you have like an urgent need, I think they have Good Samaritan laws where they cannot refuse to treat you. But in the UK, if you pay taxes, if you're a resident in the UK and you pay taxes, you get your medical treatment. It's free at the point of service. But if you're not paying taxes and you're not resident in the UK, then you're supposed to pay for it. But that's another issue. And so I decided also to check out Afghanistan because I thought that was really interesting. Because in 1952, Afghanistan's life expectancy was 28. But in 2007, its life expectancy was 43. So it has increased about 15 years. And the GDP per capita has also increased. So I thought that was so interesting. I thought I would look at Afghanistan as well. So we come over here to R. And I'm not, as in R, you can't do a for loop that's got two variables in it because I researched this. So I didn't know what to do, so I just filtered it out, US, UK, and Afghanistan. So I didn't use the same code in R that I used in Python because you can't do it in R that way. So that is one problem with R. So you can do more with Python than you can with R. So we filtered out the US, we filtered out the UK, and we filtered out Afghanistan. And so we printed them all out. So you've got the US, the UK, and Afghanistan. And now what we're going to do is we're going to check the variance. And one thing that you have to keep in mind is we're checking out the variance. But one thing that you have to keep in mind is the fact that when I used np.var, the variance was different. So I had to go into statistics, and then I found this statistics.variance, and then with statistics.variance, the variance was the same as it was in R because I wanted to make sure that all of the values were the same. So we import statistics, we print statistics.variance for US life expectancy and statistics.variance for UK life expectancy. And so we had 11.18 and then 11.417. And then we check the statistics and we print the variance for Afghanistan and the variance for UK, and we had 25.996 and 11.417. So we've got the variance for these three data frames that I've selected. So the variance for the US was 11.18, the variance for the UK was 11.417, and the variance for Afghanistan was 25.996. So the variance is the same. And so that's another thing that you have to be mindful of when working on Python and R. You have to make sure that you're using the correct function because you have different functions in Python. You've got a function in NumPy, or there function in NumPy, but it doesn't give you the same variance that you get in R. So I had to go into statistics and use the variance function in statistics, and that gave me the same value, because that's what I wanted. I wanted to have this, make sure that I was using the code that gives you the same value, because it wasn't going to do me, wasn't going to go very well for me to say, oh well, the values weren't the same, you know, because you're trying to translate code from Python to R, and so you want everything to be the same. So now we're going to do the t-test, the student's t-test. So we're going to import scipy.stats as stats, and so the t-test, the p-value is 0.749 between the US and the UK. And so what we're checking to see if the means of these two data frames or two data sets are the same. And then so you check the p-value. The p-value has to be greater than an alpha of 0.05. If it's greater than an alpha of 0.05, then that tells you that you can accept the null hypothesis. The null hypothesis is that the means are the same. So since the life expectancy of the US and the UK is so close, you can just take it that the p-value is 0.74929. So that means that you can accept the null hypothesis that the means are the same. But when we go to check Afghanistan and UK, you have a p-value of 6.89 to the negative 16. So that is lower than the alpha of 0.05, which means you have to reject the null hypothesis and then accept the alternate hypothesis. So the alternate hypothesis would be that the means are not the same. So on the first t-test we performed, we can accept the null hypothesis, and the second t-test we perform, we reject the null hypothesis and we accept the alternate hypothesis. And then so we've also got our statistics. I think that's your F value, I believe. Okay, so here we go. We've done the student's t-test. Between the US and the UK, and we had a sample of 0.7493. I just want to check something out. Okay, so here in this one it says statistic, but in R it says T, but it's this value here which is the same as the statistic, so it gives you the T. And this value here, it says it's a negative value as well, but I can't do anything about that. But that's what we're mainly concerned with, is the p-value. And so the t-test in R seems to be a lot more comprehensive than the t-test in Python. So we've got our results of the t-test in R are the same as the results of the t-test in Python, which means that the first t-test we did between the US and the UK was we accepted the null hypothesis, and then the second t-test we did between the Afghanistan and the UK, the null hypothesis is rejected. So you can see that we carried out a t-test in both Python and R. So you can see that how it's done in both languages. And me personally, you want to make sure that the values in R are the same as the values in Python, because Python has a lot of libraries. And so I still think Python is easier for me to use. You can do more with Python because we found two things that you can't do in R. One thing really. You can't make a for loop that's got multiple variables, whereas in Python you can. And that's the main thing that I found out. So I think that Python, you can do more with Python than you can with R. And that's something that I found out writing this program. And I know Python substantially better than R, but I did actually write this program in R because I wanted to show it to you. And maybe I'll take a little R programming class, and then I'll be able to do a blog post or something where I can highlight the differences between R and Python. But that's it. That's it. We've done our students' t-test. You can see the results of the t-test here. And so I think I'm going to go ahead and conclude this code review because I've covered all of the pertinent information. And I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. And thank you very much for watching my code review. I look forward to making more code reviews for you in the future.